Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert, and this is part 2 of the distribution of the sample proportion video. All right, I have one more example and one other thing I need to clear up from that last video. In the last example that I completed in part 1, I verbally said what the result meant, but here there is a written description of what the result meant. It meant that about 18 out of 100 random samples of size 120 will result in at most 12% having hearing trouble if the population proportion of Americans with hearing trouble is 0.15. So it's all dependent upon the population having that proportion, okay? So that's just to finish out the example that I ended with in the first video. And now I want to do another example. So the same problem, according to the National Center for Health Statistics, 15% of all Americans have hearing trouble. But this time, suppose that a random sample of 120 Americans who regularly listen to music using headphones results in 26 having hearing trouble. All right. What might you conclude with this information? So if 26 out of 120 have hearing loss, then we can compute the sample statistic, p hat. So p hat is going to be equal to 26 out of 120. All right. That's going to give us our sample proportion, which comes out to be approximately 0.217. All right. And so what we want to do is we already found out that the distribution of the sampling distribution of the sample proportion is normally distributed. So what we want to do now is we want to find the probability. So let me sketch this out. So we already know it's approximately normally distributed. We know that our mean is 0.15 because that's equal to the proportion of the population. And so 0.217 is going to be over here somewhere. A proportion of 0.217 is going to be over here somewhere. And so we want to know, is it unusual, right? And so we've always, in the past, to determine if it's unusual, we computed the probability here. And we want to know if that probability there is less than 0.05, all right? So we want to know, what is the probability that p hat is less than or equal to 0.217? Now, in order to find that probability, we would need to standardize that value. So we want to find the z-score, which is going to be found by doing 0.217 minus the mean, which is 0.15, divided by the standard deviation, which we calculated in the last part of this problem, which we calculated to be 0.0326, all right? So our z-score is going to be found by taking 0.217 minus 0.15 divided by 0.0326. And if you divide that out, you get approximately 2.06, all right? So our z-score is 2.06. So now we want to use our z-chart. Okay, so now remember, when we use the z-chart, it's actually going to give us, let me change my color. I'm going to change it to pink. It's going to give us this area under the curve, all right? So when I use the z-chart and I get the value out, it's going to give me this area because it gives the area to the left. And so in order to find the black area, I'm going to have to do 1 minus the area that we get out the chart, all right? So now let's jump to the chart. 2.06 is our z-value that we're going to be looking at, and we want to know the black area, not the pink area, but the chart is going to give us the pink area. So let's go 2.0, and then if I go to 2.06, it's right here, 0.9803, all right? 0.9803 is the probability that it gives us. So now let me resketch that out for you. All right, so 0.217 was here, and it gave us this area, which is 0.9803, and we want this area. So that's going to be 1 minus 0.9803. And so if you subtract that 1 minus 0.9803, you get 0.0197. So the probability that p hat is less than or equal to 0.217, or no, not less than, it should be greater than, because remember we was looking for this portion over here. So greater than or equal to 0.217 is equal to 0.0197. So that's this area. And I think I wrote it wrong in the last one, but just change that inequality symbol to be facing towards the p-hat. So we want to know what's the probability that the sample proportion is bigger than 0.217. It ends up being 0.0197, which is small, right? It's not 0, but it is less than 0.05. So we would say that that is unusual, all right? What does that mean? And so here is a interpretation for you. Let me take this off so that I can get to it. About 2 samples in 100, because it was 0.019. If you round that becomes 0.02. So 2 out of 100. So about 2 samples in 100 will result in a sample proportion of 0.217 or more from a population whose proportion is 0.15. So we obtained a result that should only happen about two times in 100. So the results obtained are unusual. So again, that number is less than 0.05. So we would say that is unusual. Okay, and there is one thing I need to go back and clarify that was mentioned earlier or in the part 1 video, and that was here where we talked about the shape of the sampling distribution being approximately normal if n times p times 1 minus p is greater than or equal to 10. Well, there's actually a second criteria that I forgot to mention, and that second criteria is that n has to be less than or equal to 0.05 n, where this N, this capital N, is the size of the population, okay? So in order to calculate that, though, you have to know the population size, all right? So if you do 0.05 times the size of the population, if your sample size is less than or equal to that, and if n times p times 1 minus p is greater than or equal to 10, then you can conclude that the shape of the sampling distribution of p-hat is approximately normal, okay? Sorry, I forgot to mention that, but I'm back addressing it now, so make sure you add that to your notes. If you have any questions, let me know. Hopefully you get what we're talking about. Please feel free to reach out if you don't. If you do, that's great. Thank you for watching, and I will see you in the next video.